use modern technology to solve problems that model railroaders might have. So he's going to show you his LaunchPad for Model Railroading project. It's a contributor-based project that anybody can put their ideas in or write programs and that sort of thing to share amongst other modelers. So I'm sure Terry will be able to explain it much more, but ask lots of questions, and we have these LaunchPads for sale at the Credit Valley if you're interested later in the day. Thanks very much. Go ahead, Terry.
Okay.
Thanks for coming in.
Thank you. As Roger said, I'm Terry Terrence, and I've been in the defense industry in the U.S. for coming up on 30 years this June. I've done software, hardware, systems, the whole gamut of things. But I hadn't programmed in 20 plus years before I started playing around with microcontrollers. Started with the PICs and then moved on to this Texas Instruments project. So what is a LaunchPad? Okay, LaunchPad is a small microcontroller development board. I'm going to see that this isn't the optimum place for the computer either. So what we're going to talk about today, our manifest, is what is a LaunchPad and what can it do for you? Why would I want such a thing? And if I do, how do I build something with a LaunchPad? Okay? And then the last section of the presentation will be on resources if you want to pursue this. Okay? So, the question becomes, what the heck is a LaunchPad? A LaunchPad is a microcontroller development board. There are many microcontrollers out there that hobbyists use and businesses use them. I've used them in my design and my work. Okay? And they use them for small control and computing functions. There are many different lines. There's the PIC microcontrollers by a company called Microchip. There are the Arduino microcontrollers, which are very, very big with the experimenter community. And then there's this Texas Instruments LaunchPad. Well, why the LaunchPad? Well, a couple of reasons why. It's inexpensive, okay? It self-programs. I don't need to have a separate programming system to get these things programmed so that I can use them. This top half of the board here programs the chip, which you insert here, which is what will be doing the execution. It's powered easily from a USB port, and we'll talk more about that in a moment. And it has male pins in these locations. They don't show in this picture, so you can attach wires directly to the pins. Okay? That's important because most of the other microcontroller boards have female connectors here, and you have to have a mating connector to get in at the signals. Okay? And by the way, stop me at any time with questions. What is a microcontroller? So I'm going to compare a microcontroller to the computer that sits on your desk. The computer that sits on your desk has a microprocessor. Then it has, as a separate item, you have memory chips, I/O chips, input-output chips, and support circuitry. Okay? The microprocessor communicates with all these other chips on the motherboard to make a functional computer. This is well and good, but microprocessors now have so many transistors, so many gates in them. They use up so much power that the amount of power available on each pin of the microprocessor is infinitesimal. And you need all these other chips so that it can actually communicate and manipulate things in the outside world. Well, the microcontroller, they put that all and more onto a single chip. So you have a microprocessor, your memory, your I/O, and your support circuits. You also have analog to digital converters, timers and counters, and generate pulse width modulation. And this is particularly important for controlling motors. Okay? So all that's on a single chip. But the most important thing is the pins have enough current to drive a load outside of the microcontroller. Another important thing is, while each pin on this system, your desktop system, has a defined and single purpose, on the microcontroller you can say, well, I need this pin to be an input, and And maybe another time you need that pin to be an output. Maybe another time you need that pin to generate pulse width modulation. You assign the function of each pin, so you basically customize the unit for your application. Okay, and this is as geeky as I hope we're going to get today. So if this made you uncomfortable, don't worry, the rest of the presentation should not. What can a microcontroller do for you? Well, you have microcontrollers in your model railroad stuff right now. You just don't know it. Every DCC decoder has one. Okay? More than modern throttles have them. All right? Sound systems have them. So they're there, you just don't know it. But there are many, many other potential animation and control uses for microcontrollers. And here are just some of them that have been suggested by people who have been interacting on the LaunchPad For Model Railroad blog. And many of these we've built. The alternate flasher, you can see it operating here on the diorama. This simple strobe on top of the tow truck on the diorama. The back and forth shuttle, it's somewhere here in this list. Bottom left, back and forth shuttle controller, you can see it operating right there. And we have many, many others. The welder effect, you'll see in the video at the end of this presentation. So all of these animation and control functions and more can be accomplished with a microcontroller. So this is what you can do with it. Now if that interests you, now the question becomes, why would I want to do any of that? Well, there are certain cost advantages in doing it on your own. We'll talk about that. You can get so it's an inexpensive microprocessor board, and the beauty of it is, this section of the board here allows you to program it. Most microcontroller boards require an external programmer, and then this is the device that's actually executing the code. And it has a series of pins here. This is an early picture of the LaunchPad, so you can attach wires directly. That's also important. Okay. What the heck is a microcontroller? All right. So in your computer on your desk, you have a microprocessor which then communicates with memory, input, output, and other support circuitry. All right? This microprocessor, very powerful, uses a lot of current, but because they want to keep the current consumption low, it sends infinitesimal signals to all of these other devices. Then these other devices communicate with the outside world. A microcontroller takes all of that and puts it on one chip. Okay, so that one chip you saw in the center of the other picture has everything it needs to execute code and interface with the outside world. Okay, so you have memory, I/O, support circuitry, and special peripherals that help the microcontroller interface to the outside world. And that's as geeky as we're going to get. Okay, so I'm not going to make your head explode. So all of this is on a single chip. Now, it isn't nearly as powerful as this, but the LaunchPad is as powerful as the old 286 and 386 computers. Okay, it's about 25 megahertz clock. So it takes us back about 15 years in computing power, but it's not designed to run spreadsheets or word processors. It's designed to control things. That's why it's a microcontroller, to interface to the outside world, turn things on and off. The outputs have enough current to drive small external loads like LEDs. That's very critical for us. Okay? The other thing is you can define all the pins on this microcontroller, you can define what they do. And that's important. If I need 4 pins driving LEDs and 4 pins doing something else, you define them in software, and that's what those pins will do. So that's critical, and that microcontrollers do that. So what can it do? All of these animation and control tasks on a model railroader within the capability of a microcontroller, and including this Texas Instrument LaunchPad. Alternate flasher, you can see it working here. If I put my hand over this sensor, or this sensor, the alternate flasher comes on. Okay? I have that one launch pad here is flashing the light on this tow truck and running the alternate flasher here. So it can do multiple tasks at once, provided that they're simple enough. So we see a simple strobe, an alternate flasher. And until my little locomotive quit a few minutes ago, it was running back and forth along this piece of track under the control of one of the other launch pads. Okay, so you have a shuttle controller. But all of these other things are possible. So think animation and think control, and that's what a microcontroller can do for the model railroader. Questions? Okay. Why would you want one? Well, first off, the launch pad is very inexpensive. It costs, in the US now, it's $10. It's more expensive up here. You can also do custom functions with it. Also, it can help us address the diminishing manufacturing base. We all know that manufacturers are going out of the market, the model railroad market, because the cottage industry guys who've been running things like Sunshine models and the like for years are retiring. And then there's also a cool factor. Okay, it's really cool to say, look, I programmed this myself. So let's do a little bit of cost comparison. Let's do the crossing flasher. So we have Circuitron, their detector and flasher together cost $45. Your launch pad, again, US prices, $10. 2 IR LEDs and 2 photodiodes, another $4. Load some free software that's on my blog. And so for a total of about $14, you can create something like this alternate flasher. Okay? So you can save money. And the other thing is, as you saw before, this alternate flasher will detect trains in both directions, whereas with the Circuitron one, it will only do a train going in one direction. If you want the one going the other direction, you have to buy a more expensive unit. Well, it doesn't quite double it, but it's more expensive. Let's take the arc welder simulator. The Circuitron circuit is $27. And we'll see, because I have a video at the end of this presentation, the launch pad, plus a couple of white LEDs for 50 cents and software, which you can get on the blog, and you can do it for about $10.50. Okay, so you can save money by doing it yourself, rolling your own, so to speak. Another important point is, what if you have a custom situation? Okay, I'm a B&O modeler. So B&O has their color position light signals, which are a 4-color system, plus 6 markers, 3 above, 3 below, for a total of about 37 different signal indications. No manufacturer is going to come out with a system that will do all that. It's just too small a market to customize it. But I can program it into one of these, no problem. Let's say you have yard routing you want to do. I want to align with this yard track and throw certain switches and not others. Again, people did that with diode matrix for years. This can do it a lot more intelligently, and once you learn to load the code, conceivably more simply. Interlocking. Interlocking, by definition, everyone's interlocking will be different. All right, so you have to have something that's customized to your layout, customized to your yard situation. Complex animation sequences. I don't know, how many of you have seen that video from Laurie Green or John Hunter, the blacksmith? So he's raising his arm like this and turning his head like this, but that's all it can do. And it does it repetitively. And it looks cool the first time, but after 5 minutes, there's no variation. It sort of wears a little bit thin. But with the launch pad, you can say, do this, then this, then this, then this, then this. You can even do random sequences, although random for a blacksmith wouldn't make a lot of sense. But the point is, you can customize complex animation sequences, which, when you think about it, can also mean if you have semaphore signals, you can move those. If you want a highball signal or something like that, you can do that as well. Cityscapes. I don't have a big city on my layout, but if you do, think about all the things you should have in a city if you want to look realistic. Traffic light simulators, which we have on the blog. Lights coming on and off in the buildings. It doesn't have to be you know, Lionel style animation where all of a sudden there's this blinding light coming out of a window, okay? But you subtly can turn on lights in some offices and even go through a day-night sequence if you want, okay? So that night falls, all the lights come up, then they eventually go off as people go home. There marquees, theater marquees, all sorts of things in the cityscape that have done with subtlety, you know, and again, we're not talking Lionel style bells and whistles, but done with subtlety can add to your layout. Diminishing manufacturing base. As I said, there are fewer model railroad manufacturers available as cottage industry operators retire. Microcontrollers fit into a paradigm that is being developed not necessarily for model railroading, but in other hobbies like robotics and other hobbies where people are developing ways to manufacture on demand. So I also do 3D printing. Okay, so I do 3D printing of O-scale items, and the way I do this is you can go to a website of the guy who actually does the printing and order one of my models, they build it for you and mail it to you. Okay, so you become, in effect, or I become a manufacturer. All right, well this fits into that paradigm along with 3D printing and laser cutting. It's going to be a way to manufacture things on a small scale and more importantly, customize each and every one. So you get only what you want. Any questions so far? Am I losing you? Okay. The cool factor. You know, you guys who were here earlier before the little loco quit and saw it going back and forth and back and forth. And I was a software guy back from like 83 to 89. That's how I made my living. Okay? So I know how to code, and I know how to design a program, and I know control theory and all of that. And this was a very simple program. Yet when I got that working, I sat there and go, man, that's cool. Okay? Even though it's relatively trivial, I go, man, that's cool. You should have seen Clark in here before. He was sitting there going, wow, this is cool. All right? And you can create things that no manufacturer has yet conceived. We talked about a couple of them, you know, custom interlocking, custom signaling systems, etc. Impress your friends and visitors, right? And you can sit there and say, I did this by programming the C programming language, and I used the Texas Instruments MSP 430G523 microprocessor. Just don't do that with anyone under 30, because they'll bust you so fast. Okay? Yeah, especially your grandchildren, because they'll go, here, full of crap. Anyway, and this may be a way to attract younger people to the hobby, okay? Instead of just watching trains go around or boring them with the, you know, minutiae of operation, say, hey, you know, I need a control system built for this. And I think, you know, that certain young people would be amenable to that. And we'll talk about that in a little bit more detail a little further on in the presentation. All right, so how do you make something with a LaunchPad? Well, you follow a few simple steps. Pick a project, and I had the whole list of projects up there. You can get them from the LaunchPad For Model Railroading blog. Get a LaunchPad, add external components program. The external components can be very simple. It can be LEDs. Okay, all this crossing flasher is, in addition to the optical detector, there are, you know, a couple of LEDs in there, all right, and a couple of resistors that you need to put with the LEDs. Program the thing, power your LaunchPad, and then sit back and admire your handiwork. Impress your friends. So pick a project. Where can you get a project? Well, if you're tech savvy, you can dream up your own project using LEDs and lamps and motors and relays and servos and all these sorts of things as appropriate for the project. If you're less tech savvy, you can find projects on the internet. If you're really a non-techie, what I'm trying to do with the LaunchPad For Model Railroading blog is to come up with pre-packaged, ready-to-go projects where you just grab the code, you have a schematic there, wire it up, grab the code, load it, and go. Okay, and these will all be for model railroad related projects. Okay? So let's talk about the LaunchPad for Model Railroading blog. I started this back in December or thereabouts, and we already have a number of projects and more will be going up. I haven't put up anything in a while because I've been preparing for this convention, but I will be posting some more projects which are a direct outgrowth of this convention. Okay? Each project will have a brief description of the theory of operation. In case you're so inclined, you can read about how it works. And that's written for the layman. We're not talking bytes and kilobytes and megahertz and all sorts of other things. A list of the target launch pad and any additional hardware, for instance, LEDs, displays, motors, servos, etc. The description of how the code works. Again, you don't need to follow that, but if you're interested, you can follow along. A schematic diagram and a pictorial block diagram will help you wire it up. Most importantly, the pictorial block diagram, so you don't have to read schematic symbols. It's just like, okay, put the LED to this pin to ground, or the resistor goes here, that sort of thing. And of course the code listing and a link to the file where you can just go and grab the code and put it into the programming environment and programming LaunchPad. And a video, which is optional, but I try to get everyone who's submitting programs to submit, projects rather, to submit a video. I'm asking everyone who posts something on the blog to make their software free for non-commercial use under the Creative Commons license, okay? And this is important, okay, because it will prevent commercial people from grabbing the code and using it for commercial purposes. And if you remember the big thing with JMRI, that dragged on for years, but eventually JMRI won out over the commercial operator who wanted to exploit their code. Okay, so you'll have no qualms about using the code because the authors explicitly grant you permission. Okay? And we accept project submissions, and any of those projects that were listed in that list, if you do know how to code or have a kid or a relative who wants to take a crack at it, and we'll put the project up on the blog. Okay? How do you obtain LaunchPads? Well, you can buy them direct from Texas Instruments, and they ship for free in the U.S. I don't know what happens when you come up here to Canada. Okay? Sorry about that, guys. I didn't think about that when I was writing this presentation. Credit Valley has them in stock for this convention. As a matter of fact, they ordered a bunch of them when I agreed to do this seminar, this clinic, and they're already sold out of those and got their second batch in. Okay, so apparently people have been interested. Other sources are the big electronics distributors like Mauser and Newark. Okay, so this is where I get mine, usually from Mauser or straight from TI, depending on who has them in stock. TI frequently runs out of stock on these. Okay, so they are popular. Adding external components. Each pin on the LaunchPad set up as an output can drive an LED directly. Use a 270 and 300 ohm resistor in series, because otherwise you do run the risk of burning out the LED. Now I'm going to have some link, say again?
What's the voltage?
It's 3 volts. Okay, so this is going to give you 10 milliamps. You can go down to as low as 120 ohms to drive 25 milliamps. Just make sure your LED can handle 25 milliamps. For instance, this LED probably does, but it's a super bright one, and this one, these are only 10 milliamps each. Servos can be driven directly as well. I'm going to have a servo project up there for a servo turnout machine at some point in the near future. I also promised a buddy of mine up in Maryland to do his semaphores with servos in the LaunchPad, so I'll be doing that as well. Now let's talk about other functions. In the track structure here, I have embedded 3 optical detectors. Now, I could have done those, following plans that are on the blog already with a separate LED, IR LED, and a photodiode. But I bought a module already made that has a sensitivity control and some other features that make it handy to use. Those modules are designed for another microprocessor, a microcontroller family called the Arduino. And these are very, very popular with the geeks, okay? So there are hundreds of these modules out there, a lot of them made in China. And there are modules out there for many, many different functions. Let's talk about a few of those. Here are some modules that I bought already. These are relay modules, single relay, and there are 3 different types of single relay modules. And then this double relay module, which is the one incorporated into this display here. A keypad, okay? So when you need to press keys to make something happen, you have a keypad. Optical sensors. This one here is what's in that track structure and detects trains as they're going by. A current sensor, okay? If you want to detect your trains by detecting the current in the conventional manner, you do a current sensor. And these are motor drivers, okay? These are just some of the modules you can buy. Some of these I got from vendors directly in China. Some of these I got off of eBay. Okay, I think this was an eBay purchase. A couple of these were. This was an eBay purchase. So one of the things to do, and I have it in the resources, is go to eBay, search for what you want, like relay module and Arduino, and they'll start popping up. And these are very inexpensive. I paid less than $3 for this double relay module. Okay, now they're all shipped directly from China. All right, so don't get upset. Just make sure you pay with PayPal only. Because with PayPal, the vendor never sees your credit card information. The PayPal pays them, deduction unit pays them. All of the rest of these all came from China. And they're so super cheap, it doesn't make sense to sometimes wire up your own. Okay? So and the hookup to these is generally simple. For instance, these relay modules and this optical sensor is a 3-wire hookup. It wants power and ground, and that's a no-brainer. And then there's an output pin. And the convention is when the output pin goes to ground, it means that the action has happened. The relay's turned on, or the optical sensor has detected something. So that's what in the computer world is called active low. So a signal is active when it goes low. Okay, so you set up a pin on the LaunchPad to read an active low signal, and then the sensor sends it, and you know something has happened. That's exactly what happens here when I put my hand over that optical sensor module, and it triggers both the alternate flasher, and you can hear the relays clicking because that would trigger the end of track for the locomotive. So that actual one sensor is doing double duty in this setup. I have yet to experiment with the motor drivers, but these have a lot of potential, okay? Because literally you can drive, these are pretty big. This is a 6 amp honking one, but it's still small enough to fit in an O-scale locomotive, and I'm an O-scale. So I'm looking forward to hooking up a LaunchPad to this and coming up with my own 6 amp DCC decoder, which I can be able to buy for about 15 bucks. Rather than 100 and change from the manufacturer. Now, is it going to be as sophisticated? No. All right, it's going to be non-sound, but a 6 amp decoder for 15 bucks is not too shabby. Actually, it'd be 16 bucks. I think that was like $6.50 for that module.
The current sensor, is that the same as like a BD20 from NCE? Or
well, it's not going to be the same as a BD20. This one passes the current through the terminals. The BD20 uses a current transformer.
Could you still run the wire in and out? Like
yeah, you run the wire in and out. And I don't remember offhand what the specs on that current sensor is, but it's probably good enough for HO. Whether I'd run 10 amps through there for O is another matter. I doubt it. Okay, but again, these are just some of the modules you can get. Literally, when I was buying most of these, the keypad and these motor sensors, the current sensors, I went to a website, a Chinese vendor, and they're in the resources, And I had like 15 pages of these modules, and I just thought, yeah, this one's cheap enough, I'd like to try that one, and like, you know, picking them all off, and bought